الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/GDG MENA.
السلام عليكم ورحمة الله تعالى وبركاته. أهلا بكم في حلقة جديدة من حلقات GDG MENA، أين سنتعلم الكثير من الأشياء انطلاقا من الكمبيوتر بيزكس، مبدئيات الكمبيوتر، إلى الكلاود، إلى الماشين ليرنينج، إلى كوتلين، إلى أندرويد. سنتعلم الكثير من الأشياء. معي بإذن الله سأقوم مرة كل شهر بإعداد حصة يمكن أن ندعوها هكذا، تتناول موضوع كلاود كومبيوتينج. قمت الشهر الماضي بحصة عن الكلاود، يعني مبدئيات الكلاود. اليوم بإذن الله سأكون معكم على مدار ساعة. سنتناول موضوع جوجل كومبيوت انجن، بحيث سنتعلم الكثير من الأشياء بإذن الله. وطبعا إذا كانت لديكم أي أسئلة يمكنكم طرحها على الشات وسنجيب عليها بإذن الله، إن أردتم بالعربي، بالفرنسي، بالإنجليزي، أي لغة تريدونها. سنبدأ بإذن الله. الحصة طبعا ستكون بالإنجليزي، ستكون هناك حصص أخرى بالعربي، لا يوجد أي مشكل في هذا. Welcome everyone. Azul Falloun, Aliane Abdenour, GDG Tizi Ouzou, Algeria. Today we are going to talk about Google Compute Engine. This is a primer course. That's why we call it hands-on Google Compute Engine. I will be with you within 1 hour. We will talk and learn and a lot of stuff. And if you have any question, you can ask them on the chat. I will check on them and I will reply. So everyone wants to learn cloud, but cloud is not that easy. That's why there are many tools developed by engineers to make it easier. Today we are going to talk about Google Compute Engine. What is Compute Engine? Last session we talked about virtualization. I told you that we are going to virtualize everything which is physical. We try to make it software. That's what we call virtualization. We take anything which is hardware and then we make it software. It will become just another process. And the unit about this, we call it a hypervisor. Hypervisor, we saw that this is the unity of measure. So every day and every time you talk about cloud, you need to talk about a hypervisor. And there are two types of hypervisor. We have the type 1 and the type 2, depending on which layer we are. So if we are just near the hardware, we are in type 1. If we are far from the hardware, we are in type 2, which means that we run, for example, Windows, and then we run the hypervisor, we call it type 2. But if we run directly the hypervisor, we call it type 1. But you need to understand that even in type 1, we have the small code that needs to be an operating system, because our hardware, it needs to communicate with a kind of software which we call a kernel. But I need you to understand those two words, a host and a guest. I will always talk about hosts and guests. So the host is the machine where we are going to virtualize The guest, this is the operating system that we are going to virtualize. So the host is one, and the guest, it can be many. For example, if we have my machine, right now I'm using a host, but when I will try to run a virtual machine, I will use guests. So you will hear a lot about VMware and Xen or XCP, which is the open source version of Xen, or you will hear a lot about VMware and VirtualBox and so on. But there is the type 1 and the type 2. But personally, I prefer that we split this on 4 categories. We have a full virtualization, para-virtualization, hardware-assisted virtualization, and hybrid virtualization. So the full virtualization, this is the less powerful one, because we need to virtualize everything. There is no tricks, so it will be really slow. And then we have the para-virtualization, where the operating system that we call now the guest, he knows that he's being virtualized. And then if we have the hardware that is compatible, then we can use the HVM using 2 types of technologies. If we are on Intel, we are using a VTE X, and if we are on AMD, we are using VTD. And you have to know that if you have a recent laptop or a computer, you need to know that there is a big chance that you have already those 2 technologies, but you need to enable them on the BIOS. And then we have the hybrid virtualization, where we try to do combine several technologies to make it the best solution. The hypervisor, you need to understand that sometimes you don't need to install them. They are already existing on the operating system, and the most known, if you are on Windows, you have already Hyper-V. If you are on Linux, you already have KVM. You need to know that quick emulation, QEMU, if you use, for example, GNS3, which emulates the network, you already used QEMU. So another thing, everything that I'm talking about, it's just what I said in last session. You need to understand that when we are in the cloud or when we are in virtualization, we have 2 types of files that we can exchange, import and export. We exchange the virtual disk, and then we exchange the virtual appliance. The difference is that the virtual appliance is just a virtual disk plus the configuration of the machine. For example, you say, okay, I need 2 GB RAM, and then I need, for example, 4 cores of my vCPU, and then instead of reconfiguring it every time, I just give you the OVA or the OVF file, and then you import it on your hypervisor, and everything will be configured. So, for example, we have a VirtualBox, we configure everything, and then we upload it on Google Cloud. We just use that format, and Google Compute Engine, it will configure itself directly. But you need to know why we need something which is already used by engineers. If you try to have your own virtualization technology on your machines, which we call on-premise, you need to understand that, for example, VirtualBox alone is not enough, because you need the network layer, because you need to virtualize a lot of machines. Here, this is not something which will be easy. And that's what we need an orchestrator. An orchestrator, in another name, that's what we call infrastructure as a service, because we try to give to rely on engineering to make it easier for us to not break our head asking how am I going to configure the network, how am I going to configure the RAM and the disk and all of that. And there are open source products, and there are commercial products. For example, VMware, it's commercial, but CloudStack and OpenStack or Proxmox or OpenNebula or Ovirt, they are open source, but there is a problem. This is not because it's open source and it's free that it's advisable to use, because sometimes, even if you have the technology, it's difficult to have the knowledge. For example, you already bring OpenStack and then you are using it, and then after 1 month there is a bug. How we are going to solve this bug? And this is the problem of open source products. They are available, they are free, you can use it, we can use it, but the problem is that we need the knowledge. And this is why there is the place where we need to pay. Even if we have the open source technology, we need to pay for the knowledge. And this is what we call the turnkey. Or we use Google Compute Engine. Google Compute Engine, this is an infrastructure as a service, or we call it an orchestrator of our virtual machines that the engineer of Google, they will handle it. And the Unity, so if we talk about like the words that we used earlier, the host is Google, and the guests are the machine we are going to use, which means that we don't touch the host. We don't know what Google is using. We don't have the right to go there. What we can use is the host, and that's what I will do in few minutes. So when we get our guest, the machines, there are predefined machines. We have the E2, the N2, the N2D, and the N1, which is the old generation. Those ones are the second generation. As you can see, in old generation, every vCPU, it has only 6 GB. But with the second generation, we have in every vCPU, we have 8 GB. And then you choose if you use the AMD or use the Intel technology. And then we have what we call preemptible. Preemptible is a machine that lasts for 24 hours. For example, we have some tasks that doesn't need more than 1 day to complete. If we choose preemptible, we are going to pay less money than a normal machine. For example, we rent, because what we do in the cloud is renting machines, renting resources. So we rent, for example, 32 GB of RAM and, for example, 8 vCPUs, and then we do a complicated task. And this complicated task takes, for example, 3 hours or 4 hours. We don't need to take a complicated machine. We choose any kind of those machines, and then we check the preemptible option. We will see that in few minutes. And Google Compute Engine, they use KVM. They don't use VirtualBox. They don't use VMware or Xen. They use KVM. KVM is initials for kernel virtual machine. But personally, I prefer call it kernel virtual module. Why? Because it's already installed in the kernel. So you don't need anything else. You just, if you have Linux, recent Linux, which with the recent kernel, you already have KVM. And in KVM, there are many options that you can have. You have, for example, a memory ballooning. Memory ballooning is, for example, you have 2 machines, 2 guests, 8 giga, 8 giga. You need 60 gigabytes. What happens is that you can go even to 20 gigabytes. Why this? Because the host, it gets back the unused RAM. So you have 2 guests, 1 host. So the host, when it sees that there is one of the guests that doesn't use much more memory, it doesn't need that, it gets it back to him. and then it sends it to the second guest. This is what we call memory ballooning. We have the live migration. We are working, there is a problem, no worries. The machine, our guests, it will be like teleported to other machines, and we keep working. Of course, we will not have the 100% of power for like 3 seconds, but at least we will have what we call the high availability. And then we need to understand something. There is the availability, and then we have the reliability. Google tries its best to give us the reliability, not the availability, because availability is not always what we want. You can have a machine which is available, but it's really slow. So what Google gives us is a reliability, which means that it's available and it's useful. And we already did a session about SRE for site reliability engineering. You can check it, it's on the playlist. And then we have the jumbo frames. For people coming from networking, we have the maximum size of a packet, which we call the MTU. It can't go beyond 115 bytes. This is, we will see that on Linux. By default, Linux gives the interfaces 40-60 bytes. And we will check that, because you need to understand that, especially if you want to host Windows. On Windows, you can have values more than this, which means that you need to bring them back to the maximum. The maximum is 1,500 bytes. This is the maximum network packet that you can have on GCP. And then there is no quick emulation. Why? Because the philosophy is that you need cloud for power. You don't need cloud to emulate Raspberry, for example, because Raspberry, you can use quick emulation to emulate the Raspberry CPU, which is the mobile CPU. But when you are in the cloud, we don't really need that. That's why there is no support for QEMU, but you can install it by yourself, because in computer science, if you complicate a system, you can have a lot of bugs and a lot of security flaws. This is why you need to have something small, but works. So in GCP, you can have quick emulation, but you need to install it by yourself. But the emulation that comes from Compute Engine, it doesn't use quick emulation. It uses directly KVM. And the network layer is called Andromeda. Andromeda is a software networking technology owned by Google, which lets you have a global network resources. For example, Amazon is not global, it's regional. But in Google, you need to understand that if you have a resource here, you can communicate with another resource here. And in Google, it's split on the regions, and every region there is zones. A zone is the data centers. For example, we have data centers in Hong Kong, in Taiwan, in Seoul, in Belgium, in Doha, in Madrid, in USA. But you need to understand one thing which is important. When we use high availability, because we need, for example, I'm in Algeria, I need to host a solution where it's always available. So people in USA, they can have a server here. People in Europe, they will have here. People from Middle East, they will have here. The problem is that there are many laws here and here, and you need to understand how the local authorities treats the data. Because, for example, in USA, this is not the same thing as in Europe. This is why you need to understand that if you host something in Europe, this is 90% more expensive than you host it in USA. You need to understand this concept. I just wanted to tell you this because many people don't give this big importance, but you need to understand this importance. And how we can use that in Google, you already have a free tier, which is every product they have its quota of usage every month that you can reload it in every month, and plus you can have for 3 months $300 that if you exceed the free quota, you will have the 300 for free. Or we can use the quick labs, which we will use now. So let's go to the practice, because this session is not about the theoretical side. The theoretical side, we talked about it last session. Now we need to practice. This is slides. It will be shared now. Now let's go to Quick Labs. Quick Labs, this is Quick Labs. This is the official e-learning platform of Google. It's not free, it's paid, but in the sessions that we do, Google gives us free access to Quick Lab, which is for 1 month for free. You can do unlimited labs for free in 1 month. So you just need to enable the token and you are in. So what do? I do join, sign with Google. Of course, there are other sessions talking about how we can enable Quick Labs, because we don't have enough time to talk about this. So this is out of our scope. What is important for me is that I will show you how GCP works. So I will take any kind of any lab just to test it. So let me, for example, set up network. My objective is not use the network. My objective is to have the access to run machines. Okay, so you just need to go to any lab and then you do start lab. I'm not a robot. You need to have this. If you don't have this, you need to refresh, disconnect, and reconnect to ensure that you have this. If you don't have this, which means that your free month is not enabled. So I use this free subscription, and then I open a new Incognito window. Why I do this? This is to not have confusion between my account and the temporary account that Quick Labs gives me. So I open new window, I copy this, I come back to the Incognito mode, I paste it, and then I copy this email, paste it. Notice that this is not Gmail, this is Quick Lab. And then I copy this password, I paste it. This is just credentials about your class. This is a learning. And then I do accept. This is easy. I just confirm this is like next, next, next. I don't need something complicated. Okay, waiting to load. I show you just a small on-premise solution. So if I access to this, admin, type the password. This is something that I host by my own, but there is a problem. It doesn't mean that if you host it by your own, that means because it's free, that means that it will be useful with time, because there will be bugs, there will be hardware that you can lose. But when you host it on Google Cloud platform, you need to understand that if a disk fails, it's on the charge of Google. Google will replace it for you. But if you host something by your own and you lose a disk, you need to go and buy a new disk. So think about this. And okay, how about this? Okay, it's loading. Okay, I agree. And this is the interface of GCP. So if I zoom on it, here we are. So as you can see in the left side, we have, it's organized by types. Compute, this is CPU, this is the machine, and then we have the storage, the disk, different technologies. We have databases, and we have the networking, and we have a lot of other that we will see with time. So what is important right now, I come to compute engine, and then I type here, I click here to pin it. And then I come to network, I need it, and then I pin. And then I come to compute engine, I click on it, that's easy. Now, how difficult is creating a virtual machine? Maybe it will be difficult on your on-premise, but on compute engine, you just do create. We click on create, we give a name, we choose our machine, our zone. I will come back here just to show you. I just come here and then I do create. That's it. I will have a new machine. But if I wanted details, let me do details. So let me zoom here. I will call it my test. By the way, in Quick Lab, you need to respect what they ask you to do. If you don't respect that, you can be blocked. For example, I tried to change a machine. I tried here to use a stronger machine. I got banned. So I contacted them and then they unblocked my account. So you need to respect what they ask you to do here. So if I come here, you see those instructions? You need to respect them. What they ask you to do, you do it, but you are free to do something else once you finish the lab. This is my own way to learn because it's free. So they give you only what is asked here. So sometimes you want, for example, to do something complicated, you get banned because you are using more quota than you should. So let's explain it. I have the name and then I choose a region. So if I come here, I need you to understand one thing. So let's open Google Platform. Okay, let's open this. Here is Google Cloud Calculator. This is, I put the link on the slides. You can have them. So this is useful to see how much money it costs to host a compute engine. So if I use one instance, so here you choose the product, I choose compute engine, and then I want only one instance, and then I come here. The difference between operating system is that there are operating systems that are free, and there are operating systems that are paid. So you don't need to break your head with licensing when it comes to paid operating system. Google handles that for you. So I will just choose a free, which is, for example, Ubuntu or Debian, and then I have a machine which is E2, and in E2, let me choose a small one. For example, 1 giga. Let's have the basic one, because in E2, if I choose, for example, N2D, you need to understand that you will not have a weak machine. To have weak machines, you need to choose E2. So in E2, I have, for example, 1 vCPU, 4 GB of RAM, which costs less money. And then look here. If I choose USA, Iowa, and then I do estimate, I do add to estimate, I will pay $48 in 1 month. But if I come back here, it's the same machine, huh? And I choose Europe, for example, in Frankfurt, in Deutschland, in Germany, and then I will do, oops, let me close this, and then I will do, what did I, test. Sorry. Okay, in Germany, and I do at estimate, check that it costs $63 by 1 month, which is more expensive than hosting it. Now, this is 63, remember, 63. I come back here, and then I use Iowa, 63. And then I use one instance, and then add to estimate, 48. You see, there is more than $10 in difference. So be careful when you host a machine. This is not that it is near to you that it's better to use it. You need to check about regulation. Maybe you don't have the right to host it on another country, but if you can host it on another country, USA is the most cheap solution when you want to host in cloud. Okay, let me come back here. Where I was here. Okay, so I leave this as it is. Now, enable the confidential computing service. You need to understand that there are now attacks that attack directly the RAM, which is dangerous. So if you enable this, you need to understand that no one can attack your RAM because it's encrypted. So it's an option. And then this option is if you want to deploy something on Kubernetes. So you already have a container. If you see here, the link is GCR, which is for Google Container Registry. So if you already host a container on this website and you upload it, then you can directly deploy it. We are not going to deploy it. We are going to deploy a normal disk. So we click on change, and here we have a public image. What does it mean? It means that those public image, they are pre-configured by Google. So if I choose a family, for example, I come to Ubuntu, and then I come to this version. This is the same that you will find in Ubuntu in the website, which is ready. If you want to customize your own, we will see that in few seconds. Custom image, this is something that we already customized, but we didn't do that yet. So we will use the standard image. And the size, you can use, for example, 40 gigabyte, and then you can come back always here and calculate how much it costs, always. You can come to Compute Engine and then check how much money it costs for you. So always use this website to calculate how much it costs. So let me come back here. Now, what is the difference between a snapshot and a custom image? You need to understand that a snapshot, it's what we call incremental snapshot. So the first time, for example, it will take in, like, let's call it a picture of your image. It will be, for example, 20 gigabytes. And then if you do another snapshot the second time, it will not take 24 gigabytes, which is the double. It will take just another, for example, 1 gigabyte. So at the end, you will have 30 gigabytes. So a snapshot, it doesn't do something like multiply by 1, multiply by 2. If you do 3 snapshots, you will have multiplied by 3. It's the technology where it will only records what is different. Existing disks, this is what I already used. So let's have this. And you need to understand that if you want something expensive, you use SSD. If you want something cheap, you use standard, which is HDD. But you can use balanced between two. Select. And I come back here. Now, what is a service account? A service account is something like a program that asks, because you need to know that right now, Google is on what I am doing now. It will send what we call an API. This is like, do this, don't do this. This is what I told you about Quick Labs. Quick Labs, when we initialize a new classroom, we have some APIs that are enabled, and then we have some APIs that are disabled. If you want to use your own account with your own money, you need to understand that all APIs are disabled by default, because if they are enabled, that means that you can use something that you don't know and that will cost you money. So better to disable all of them and then enable only what you need. So I will use the default one that I already got initialized right now, and then allow default access, or I can check which API I will enable. I will use the default one, and then this is for people who don't want to break their head with firewalls. Because if I do just allow HTTP, I don't need to go to the firewall and then configure my own rules. I just do allow HTTP and that's fine. And then we need to check this and come to disks and then uncheck this. What happens is that now if I initialize a new machine and then delete it, the disk will not be deleted. And this is what we use in on-premise. So if I come here and then I use TrueNAS, this is like the NAS. It's based on OpenBSD that you can use to share disks. This is what we use in production. You have TrueNAS, which is the next generation of FreeNAS. Because you need to understand that you always separate the disk, which is the data, from the CPU, which is the logic. That's what we said in the last session. And then here, if you want to encrypt your data using Google generated key, or you want to give them your own key if you don't trust them. Okay, the device name, how I'm going to name it, and then the networking, you need to know what's going on. So let me come to VPC network, which is virtual private cloud. By default, every time you initialize a new machine, every time you initialize a new session, you need to understand that Google gives you a new VPC by default. So every region has its own internal network. So if you use subnetting, this is those are if you have advanced knowledge in networking, you can generate your own subnetting. And if you check here, as I said earlier, you cannot have jumbo frames. The maximum is 1046, or you can have it to 150. Okay, so let me go back and generate my machine. I hope, oops, sorry, I lost the configuration. That's not a problem. So let me come here, and to the disk. Let me go to the disk and let me choose Ubuntu. And in Ubuntu 20, which is LTS, and then everything is here. And let me uncheck the disk to not be deleted, and then that's fine. And let me create, and that's it. I just created my first machine. And when you create a machine, you need to understand that to access to it, you need a protocol, a network protocol. And what is used here is SSH for secure shell. So it's being baked, let's call it baked. So right now I'm trying to generate what is the host and what is the guest. The guest is this machine. The host is Google. Google is always the host. What I'm trying to generate is the guest. So as you can see, I already generated a new guest. Let's click on SSH, and then I will have, let's dismiss this, Cloud IRP. I have, for people who use PuTTY, this is the same as PuTTY. So let me zoom, and then if I type host name, this is the name I gave it by default. So right now, when I type something, for sure I'm typing it on my machine, but the operation doesn't happen in my machine. It happens at Google. So if I do hostname and FQDN, full qualified device device name, you need to understand that it's 3 names, because when you use an on-premise solution, you need to split it like this: A.B.C.D. So, for example, I will have, for example, Aliane dot home dot local. This is FQDN. Anyway, we will talk about this in advanced topic when we will talk about network. Now, let's see what is used at Google. Do they use virtual machine? Do they use VirtualBox? Do they use Hyper-V? So let's check that. So we just type host name, control, and then we add our argument. So hostname control is a Linux command, and then we tell him, give me the status. So I need sudo, and okay. So what does Google uses? They use KVM. That's what we said earlier. They don't use quick emulation, they don't use VirtualBox, and so on. Now, I need another command. So if I do systemd detect virt, it will give me directly the KVM. So Google uses KVM. This is the technology used in virtualization. But how about the host itself? So let me type this command, sudo and lshww, sorry, sometimes I use French, class and system. So I need to install it. apt install lshww. That's a good thing. So we can, what I did, I need to do apt update. This is like what we have the habit to use in Linux. So I install everything. I'm using the Google connection, not mine. My connection is just to view what's going on. And let me install this. Yes, by default. Everything runs fast, which is good. And then if I check this, so if you see, this is a Google technology. We don't know what is it. People from Google, they know it. They don't use VMware, they don't use Hyper-V. They use their own technology, and then they use KVM to use what we know in Linux. So let me exit this and show you a last thing. So I come here and then I delete the machine. Let's delete it. It will take some time. So waiting for this, let me check about questions, if there are any questions. Okay. Any questions? Okay, it's running. No question. Okay, it's already deleted. So let me create a new other machine and then come to disks. So if I come to disks, this interface when I zoom, and then if I come to existing disks, you see my already deleted disk. So if I do select and then I come here and then I do create, when I access now, I don't need to reinstall the command I already installed with apt update and then apt install and so on. So it's a good option if you need to initialize a lot of stuff and then keep them if you want to use them alternative. So I'm waiting just a few seconds. Okay, let me SSH to this. This is the internal IP and this is the external IP. This is this IP doesn't last forever. So every time I create a new machine, there is a new IP. This is why you need to reserve a new IP by your own, and you need to pay for it because IP addresses are not free. You need to understand this. Okay, let me come here, let me zoom, and if I use, you see, even my history is saved. So if I use this command, it will work. I don't need to reinstall it again. So this is the first trick I need you to understand. The second trick I need you to understand is that if I come here and then I delete my machine, this is really important to understand. And I come to VPC network, and then I go to the VPC that Google gave me by default. I go there, and then I delete it. So if I come here, okay, the interface needs to, so let me delete the VPC. It's being deleted, so it's a job, it's a scheduled job that runs on Google servers. So if you want to, I prefer to leave that in networking session where we will dive deeper in networking. So it will be a free Cisco course on GCP. Okay, it's being deleted. So I go back to Compute Engine. This is the good thing when I told you that to pin it, because when you pin something, you don't need to come and scroll back to it. And then if I come to create, I would recreate a new machine, and then I will wait until the network will be deleted. As you can see, it's being deleted. Someone will say, okay, this is machine. It doesn't have anything to do with networking. But if I do create, oops, I got an error. Why? Because I don't have a network. So I need to recreate a new network to be able to create a machine. Why? Because, oops, I got a bug. Okay, no problem. Okay, let me come back here. Because as I told you from the slides, Google works in a way to connect everything to their network. So if you break the network, everything will be broken. This is the main difference between using VirtualBox, for example, in your machine and using something on the cloud. Something on the cloud, the first thing you need to understand is networking. Once you understand the networking, then you start working with virtual machines. This is it. I hope you understood the basics. The last thing I need you to do is I come here, okay? Let me compute engine, not this one, this one. Okay, so let me go back to the VPC network, create a new network. And then when I create a new network, I have the choice to use either a default one or a predefined one. So let me name it any kind of word. And then automatic, a custom network is, as you can see, you need to understand what is subnetting. But automatic, it will directly generate a new network with /20. And then I activate those default rules, which is ECMP and SSH, or for example, RDP if I have a Windows machine. And then I enable global As you can see, you have regional and then you have global. And if you see here, this is what we call talking about jumbo frames. So let me put 1050. Waiting for that, let me run Cloud Stack here, so I can show you what is the default value in any Linux distribution. You need to understand those concepts. Okay, I'm waiting for the network. You need to understand that network is much difficult to do than a machine, because a network is, it's a network. Okay, I'm waiting, so let me check if there are other questions. No questions? So the strategy about those courses is that we start by computing, and then we go to the networking, and then we go to the storage, and so on, until within a year, 12 sessions, you will be someone who can use GCP. So I created the network. As you can see, every region has its own internal IP, and then I come back to Compute Engine, virtual machine instances, and then here I need you to see something. So this one, they have a bug. Let me delete it. Create, and then I will show you something. So as you can see here, look. So this one, for example, it has 128 gigabyte of memory. So it's really huge. So if I come here and, okay, where am I? If I check this, always think about the API definition. So if I check this, I cannot delete the machine, which means that the API will tell me don't do that. I will not allow to do that. So this is what we call the API. We have an interface, and then we can ask the interface what enables and what disables. And what was said earlier about preemptible is a machine that lasts for max 24 hours, and it costs really cheap. So if you have a strong calculation, you just, for example, let me take a strong machine on AMD, and for example, 256, I will not enable it because they will block me again. And then if I check preemptible here, I will use this machine, but I will not pay a lot. Why? Because it will not last more than 24 hours, but I will do good calculation. For example, I have many data, and then I need to do machine learning or some kind of complicated task. I just choose this option. Okay, if I do off, and here, that's what I told you earlier about live migration. So when there is a maintenance, because Google needs to do maintenance on the hosts, because the guests, that's fine, you do the maintenance, but the host, if it crashes, everything will crash. This is what happens if I crash my PC, this machine will crash too, because this is a guest, this is a host. My machine, Windows, is a host. So when Google do the maintenance, you choose what happens. You terminate it, or you just migrate. When you migrate, I found an article, it seems that it takes less than 3 seconds. And when we say it's Google, it's about reliability. So which means that in 3 seconds, it doesn't stop. It will work maybe at 70% of performance. So you just do migrate, and this is what we call live migration or teleportation. Every technology has its word. So for last, let me come to Ubuntu. This is on my machine, and then let me zoom here, and then let me check on IP. So if I come here, The value about MTU, so this is 1050, 1050, and 1050. But if I go to the loopback localhost, you need to understand that this is something that doesn't have to do with external networking. This is why I don't have this value, because I'm internal. This is the loopback. It doesn't go beyond my machine. This is why I have this value. But every interface that goes to the networking, it will have this value. Yeah, it keeps crashing. Later I will check what's going on. Okay. Do you have any questions? And don't forget to enable your free month in QuickLab. Or if you want to get the $300, you just go and register. Yeah, $300. This is not Google will go pay you $300. This is when you use GCP. For example, if I come here, when I say $300 and then I do estimate. So let me come here and then I will do, for example, 2 instances, and then I do add to estimate. The $300 means that Google will take $97 every month in 3 months, which means that you can use this machine for 3 months for free. That's it. It's not cash. Okay. Do you have any questions? Still 3 minutes. And of course, there will be other sessions. There will be like networking, advanced networking, Kubernetes, and hybrid cloud. There will be a lot of stuff. We are still in the second session. There are still 10 sessions together. And then there will be other session with my colleagues. So don't worry. Okay, thank you very much. I hope this session was useful. Stay safe and see you next session.